Now, because we already know what is accuracy and precision, okay, now we can go for the next definition, which is called error. Error basically means measuring something wrongly. Okay, there will be a difference between the actual value and the measured value. Then that difference between the measured value and the actual value, or sometimes we also call it as sorry, the correct value, is known as error. Now, for example, let's say again we have to measure the length of a pencil, and the actual length of the pencil is 5.5 centimeter, which is given or written on the paper or the package of this pencil. Then when we measured it for the first time, the measurement is 5.44 centimeter. Okay, so as you see, it is very close to the length of the pencil, so this is actually more accurate. Length of a pencil is 5 point, actual length is given to us as 5.5 centimeter, but when we measured it by ourselves, the length came as 5.44 centimeter, which is less. So the error in measurement is 0.1 centimeter. There is a difference of zero point 0.1 centimeter. That is what is known as an error. Now let's say we have repeated the measurement process for the second time, and when we measured the length of the pencil for the second time, it came around, let's say, 5.75 centimeter. So if you compare this actual length and 5.75 centimeter, we will see that the difference or the error in measurement is 0.20 centimeter. Okay, so the difference between the measured value, which we have calculated, and the actual value which is given on the paper, is known as error. Then there are different types of error. Basically, when we study error, then this error can be divided into two types. One is called systematic error. Okay, and the second type of error is known as the systematic error is mainly due to inaccurate instrument. Let's say the instrument itself which we are using is not good, it is not in a condition that is helpful for measuring the instrument, measuring the value. Then very importantly, there is something called zero error. So we will discuss what is this zero error, that also represents a faulty instrument, but this can be corrected, or we can correct the instrument itself. Then carelessness in the measurement. If we are not paying attention in the measurement, if we are not focused during the process of measurement, the scientific values could be erroneous, it could be incorrect, or it could be misleading. So it is very important that we pay attention to what we are measuring. And then also, the last type is wrong technique. Sometimes it is very difficult to use one technique of measurement for the another technique. For example, we can measure the length of a pencil using a scale, but we cannot measure the volume of water using a scale. Even if we put in a square container, it becomes a little bit difficult. So depending, so there is a so you will be knowing that, you will understand in when we will do the experiments, that there is a different technique we use for many different processes in order to avoid this problem of getting error in the measurement. Then the second method is known as random error. So random error could happen anytime. It has nothing to do with deal with the instrument. It could be also done, the error in measurement could also be done by a person who is measuring it. That does not mean that the instrument is faulty. The measuring method that we have choose, there have been some problems while measurement, that is why we are obtaining this random error. So random error is a least count error. Okay, we will discuss in the coming slide what is a least count error, and it is very very important, in particularly when we will do the experiments in the lab. During experiment, zero error, least count error, and also there is something called parallax error. We have already studied parallax method, and there is an error related to that which is known as parallax error. which many a times you will see that this is going to happen. You will be getting a different value, and your friend will be getting a different value when measuring the same length or the same distance. So first of all, what is a zero error? Zero error is nothing but it's a technical term. It's a very technical term which means how far away from the zero is the reading of an instrument when the real value is known to be zero. That means uh, we know that there is a zero on a scale, but many lab instruments, they obtain values by comparing two or maybe three scales together. Two different scales are compared, and then this zero value is obtained. Now during the process of getting zero value, sometimes there could be instrumental error, or sometimes there will be reading errors. This is basically an instrumental error. Okay, so the instrument is not showing zero, so therefore it can be corrected. Then the also very important, a zero error, it can be either positive. The error can be the answer of error can be in plus, and answer of error could be in minus. So what is zero error? First of all, let's say we have these two scale. In the laboratory we are going to use something called vernier caliper. In this vernier caliper, what we do is we compare the upper scale, which is known as main scale, and also the lower scale, which is known as vernier scale, that we will see in the lab. But here the value of 0 is obtained when the lower zero line and upper zero line both coincide. They form a straight line. So if upper zero line on main scale and 0 line on vernier scale, if stand in a form a straight line, or they stand together, then we say the value which we are reading is 0. But here if you see in this case, the vernier scale, the lower scale is ahead of the zero value of a main scale. So there will always be two scales, one main scale which always remains fixed, and the second one is vernier scale, which keeps on changing depending upon what we are measuring. So as you can see, the zero line at the bottom scale, at the lower scale, is ahead of the zero line on main scale. Such error, so that means there is no zero here, but there is zero error. That means positive, or we call it as a positive zero error. So whenever the reading on the lower scale is ahead of the zero line on main scale, we call it as a positive zero error. Okay, and this can be rectified. Then again, if the zero line on the lower scale is behind the zero line on main scale, so then we say the zero error is negative, because this value is counted as minus, and here the error is counted is in plus, because this here the lower zero line is in ahead of a zero line on main scale, and lower zero line is behind the zero line of the main scale. Then what is least count error? Very very important. What is, first of all we should know what is the meaning of least count. Least count means the smallest value that can be read using a scale. For example, when we have a metric scale which we use in our geometry box, which is there in the geometry box, and we use for drawing straight lines in the notebook, the smallest value that can read is 0.1 millimeter. Okay, because 1 centimeter is made it divided is divided into 10 equal divisions, and then every division basically is equals to 0.1 meter. So our scale that we use in class, that scale could only measure 0.1. Okay, and sometimes there are scale that can measure 0.0001. So there is a difference. So because 0.01 scale cannot read the values which is read on 0.001 scale, okay, so that is what leads to an error. So a least count is always calculated. Remember, this formula will be very useful in the laboratory for writing practical records. So I hope everyone will pay attention, and this will also come in 12th standard. because this forms the basis of laboratory work. So least observed unit, for example, on our scale, how we'll calculate the least count is on our normal scale. The least observed value is 1 centimeter. The bigger value that we obtain is 1 centimeter. So the smallest value is 1 centimeter numerator, and in the denominator, how many divisions are there, how many lines are present between 0 to 1 centimeter, that will be 10. So 1 centimeter divided by 10, it will become 0.1 millimeter. So 0.1 millimeter is the smallest value that we read. What is least count error? Error associated with resolution of the instrument. So like I told you, some scale could read the smallest value as, like our normal scale can read the smallest value 0.1 centimeter, but a different scale could read the smallest value as 0.0001. Okay, so when we read values using the smaller value scale, so we will be reading the values accurately, but when we change it to normal scale, it becomes very difficult to reach to a preciseness means there should be digits after decimal. So for example, 3.142 is a precise value and 3.1 is not precise. Getting me? That is the difference. So least count error is due to the scale itself, a measuring scale that we use. Then next is parallax error. Parallax error is a personal error. Whoever is taking the reading, that can make a mistake to end up getting a parallax error, and the readings will give you the wrong result. Then error caused in apparent position of the object due to weaving angle. So we have seen in a parallax method, what we have seen, that from one point, if we observe something, it appears differently, has a different position, and when we observe from the right hand side, it gives us a different position. Similarly here, as you can see, when reading a scale, when we read from this side, we will obtain a different value. Here it is 4.9 centimeter. When you read from this side, we will get a different value, which is 4.7 centimeters. So in all the lab work, it is instructed that all the readings should be taken by keeping a scale perpendicular. Always keep your eye on the point where we want to take the value. If we change the position of our eye, see the value changes. Instead of 4.8 centimeter, we are getting 4.9 centimeter. Okay, and when 4.8 changes to 4.9 in laboratory work, it causes lot of problem. So it is very important to pay a look at the readings with a straight eye. Keep your eye on the point where you want to read, no left, no right. Okay, and then similarly here also in chemistry lab, you have to take values from this pitot tube. This pitot tube, basically, if you want to look at the uppermost layer, if we want to, this is known as, the uppermost layer is known as meniscus. So if we want to take the position, generally in chemistry you will have double meniscus, upper meniscus and lower meniscus. So if we want to take the value of lower meniscus, then we have to keep that point exactly in front of our eye, otherwise there will be problems. See here, when we are looking from the bottom, the value read is 9.82 millimeter, and when we are looking from the top, the value read is 19.62. So that's all for today. Thank you very much. Hope all of you understood. Any doubt, you can message me anytime. Stay safe.